Okay, now we're going to hear from Bhavish Dinakar from the Department of Chemical Engineering. Bhavish.
When I was a baby, I accidentally stuck a fork into an electrical socket. Gave myself quite a shock. My friends say this explains a lot about me. But perhaps that was the spark I needed to become interested in electricity. Now, like Dr. Yi, I'm getting my PhD in chemical engineering, and as a chemical engineer, my job is to make materials out of chemicals, things like fuels, plastic, medicine, fertilizer, you name it. The problem is, a lot of the chemical reactions to make these materials are really slow. So to speed them up, a common technique that's used in about 90% of chemical processes is to add a catalyst, which is simply something that you add into a reaction to make the reaction faster. This is actually something we've all experienced in our daily lives. If you've ever drank a bottle of soda, you might notice that the soda sitting on a table looks like a liquid, but when you drink it, it forms bubbles in your mouth. That's because the liquid-to-gas reaction to form the bubbles is really slow, but your saliva contains a protein that is a catalyst for this reaction, making it bubble in your mouth. And although we have catalysts for many processes, these typically use either heat or pressurization to make the catalyst actually usable. And with the world moving towards renewable energy, my research aims to use the power of electrical charge as an alternative method of making these catalysts better, by basically treating the catalyst like a fork and sticking it into an electrical socket, but in a much safer way. The idea here is we connect our catalyst to one end of the battery, so the catalyst develops a net electrical charge. And then we explore how the charge of the catalysts affects the rate of the reaction. And the results that we found are frankly quite staggering. We found that for every 60 millivolts of battery potential, the reaction rate increases by a factor of 10. That means with the standard AA battery, about 1.5 volts, we can make a chemical reaction happen in a second that without the battery would take longer than the age of the entire universe. Pretty crazy stuff, right? And the best part is, because we don't complete the circuit, the battery never discharges during this whole process, so no additional energy is consumed. And although we don't know exactly why this is the case, we hypothesize that really strong electric fields exist at the catalyst surface that our models predict are about 1,000 times stronger than the electric field that drives a bolt of lightning. So in the future, we're really excited to see how this method can be used to make chemical processes more efficient and sustainable. And remember, like I learned the hard way, don't try this at home. Thank you.